Hello everyone, and welcome to today's class on refraction. So we're going to begin the class by looking at these three images below. So what I'd like you to do is to answer these two questions about the images. So why does the image of the object change when viewed through water? And can you name the process occurring in each picture? Pause the video here, have a go at that. Okay, so I hope you've had a go at that. Now, what can you see in each of these pictures? Well, when the object is viewed through water, we can clearly see as these two images that the object appears to be bent. And you can also see it to some extent here, although you do notice here that the object looks particularly large, but this is also because light is actually being bent, okay, in all of these. And this process of light being bent is called refraction. And that's what we're going to be learning about in today's class. Okay, so our learning objectives today are to describe how refraction occurs between different mediums. We're going to be making predictions of the direction of a refracted ray, and we're going to explain various applications of refraction. All right, so let's imagine yourself running along a beach towards the water. All right, let's think about this question. Would you be moving slower in the water or on the beach? Pause the video here, have a think about that. Okay, so I hope you said that you would be moving slower in the water. Can you think about why? Again, very briefly, think about that. So this is because there is a difference in density. So when you're running through the air, the density is very low. Whereas when you enter the water, the density of water is much higher, and this slows you down. Now, this is also related to light. Okay, so the speed of light also changes from one medium to another as the density changes. And this is what causes refraction. Okay, so a couple of analogies to show how refraction occurs. So imagine all these people are sort of rays of light. Now we've got an army of people marching, and they are marching at an angle to the sand. Now, if we follow a row of people, let's say this row of people, you can see here that this soldier is going to reach the sand before this soldier. Okay. Now, we all know that walking on sand is harder than tarmac, so we can walk faster on tarmac. So when this soldier enters the sand, then he's going to slow down, and then there'll be sort of like a chain reaction going on. So this one will reach, he'll slow down, and so on. And the result is there's slight bending going on, as you can see in the diagram here. The same can be shown with the truck. All right, this wheel in the truck is entering the mud first. So we've got road here, mud. So this wheel is going to slow down first. This wheel will keep going at a faster speed. So the truck will actually bend slightly to the right. Okay, so in your own time, you can go back, and these comments will review just what I've talked about. But the most important thing to remember is that refraction is due to changes in the speed of light when it goes between two different mediums. All right, for example, air and water. Okay, so I've got a little activity for you. It should take you about 10 minutes, and you're going to need a glass of water and a pencil. So you should set it up like this. All right, with your pencil in the water. I'd like you to sketch a very simple diagram showing what you can see, and then I want you to write a couple of sentences explaining why the pencil appears to be bent. Okay, pause the video here and have a go at that. Okay, so I hope you had a go at that. So the pencil appears to be bent. Well, let's think about why. So we know the real pencil is actually straight, it's not bent. But let's say we've got light coming down here and reflecting from the bottom of the beaker. Now, let's look at this reflected ray. All right, now as it comes to the end of the beaker, it's going to change medium. So it's going to go through refraction, which will bend the light. So the light reaching the eye has been refracted. All right, but the brain makes sense of the light as a straight line, because light normally travels in straight lines. So what we see is the pencil actually being here, because this is in line with our eyes, even though the pencil's here. Okay, so that's what's going on there. So hopefully you wrote something similar to that. Okay, so we've got a little investigation to do. Now, I've got a little video to show you, all right? And it's going to be we're going to investigate two things. We're going to be looking at refraction. So we're going to look at how changing the angle of the incident ray affects refraction. And then later on, we'll look at how changing the medium affects refraction. So what I'd like you to do is, first of all of you will need to watch this video. This video is going to demonstrate the experiment we would have done had we been in class. And then after you watch that video, then you're going to still conduct the experiment, but we're going to do it as a virtual experiment. So if you follow this link here, it will take you to this experiment. So if you just press go there, now this is our light, and we can change the angle that it's going to strike the medium. So we've got the medium here of air, and we've got a medium of water. If you press go, it's going to refract the ray. You're going to see a refracted ray. We'll get rid of this ray because this all confuses you. This is simply just the reflected ray, so we can hide the reflected ray. And then what we can do is we can get a protractor out, put it down in the center here. And what we need to do is measure two things, the angle of incidence and the angle of refraction. Remember, you always measure the angles from the normal line, which is this dotted line here. So here we've got an angle of incidence of 60 degrees. Here we've got an angle of refraction of 40 degrees. So you'll simply change the angle. So you're going to do 20, 40, 60, and 80 degrees. Okay. And you will record that on a piece of paper in a little table you're going to draw here. Okay. So have a go at that now. If you finish that, you can think about these questions listed down here. All right. Pause the video here. Have a go at that. Okay, so I hope you've tried that. Now I've got some example results here. All right, now I'd like you to think about any relationship you can see here. So I is our angle of incidence. This is our angle of refraction. Okay, so what I want you to think about, is there a relationship? Well, personally for me, I can't see any relationship between the variables. For example, if we double, let's say, so double the angle of incidence, let's say from 30 to 60, are we going to double the angle of refraction, 20, 35? No, we're not doubling it. Okay, so there is not any real relationship going on here. Okay. Now, what I want you to do now is do our sort of second experiment, which we're going to go back to look at this virtual experiment again. And what you're going to do here is you're going to change the different media. You're going to change the mediums. Now, a very, very important thing here is that we must keep the angle of incidence the same. All right, so if you choose 30 degrees, then you need to keep that the same. If you choose 40, keep it the same. All right, that's very, very important here. Okay, so I'll just take you through to the experiment again. And what you've got here is you've got your light, and you've got different mediums to choose from. So let's say you choose air here, and then down here, let's choose diamond. And what you'll do is just simply, like last time, measure the angle of incidence. Okay, so what I'd like you to do now is to spend 10 minutes conducting that experiment, and then you're going to record the data in this table here. I'd also like you to think about these two things here. So is there a relationship between the density of the medium and the amount of refraction? I'd like you to describe what happens when light passes from a less dense medium to a denser medium. All right? Does it bend towards the normal? Does it bend away from the normal? Think about these questions. Come back here in 10 minutes time. Okay, so I hope you've had a go at that. So let's look at some of the results. So hopefully you found that the difference in density has a big effect on the refraction. So for example, if there's a large difference in density, for example, between air and diamond, there's a big difference in density, we've got a large refraction going on here. All right, that means we've got a big difference in the size of the angle of refraction and the angle of incidence. Whereas air and water, which are closer together in density, there's still a difference in density, but it's much smaller, you'll see the refraction is much less. Okay, now what's really, really important, what you might have noticed from the experiment, is this, all right? So we must make sure we know this. This is that when light moves from a denser medium to a less dense medium, the light refracts away from the normal line. And when light moves from a less dense medium to a denser medium, the light refracts towards the normal line. So we can see that in this diagram here. Here we've got our ray of light. It enters the glass block, which is more dense. So the light's going to slow down, and it's actually going to bend or refract towards the normal line. You can see it's moving towards this normal line. On the other hand, when it leaves the glass block, it goes into a less dense medium. It increases its speed, and you can see that the angle of refraction is increased, and it's moving away. It's going away from the normal line. Okay, so what we're going to do now is you're going to copy this in your book and spend 5 minutes filling in these gaps. All right, so pause the video here, have a go at that. All right then, so let's quickly go through those answers. All right, so when light bends, this is called refraction. Refraction happens because the light changes speed. When light enters a more dense medium, for example glass, it bends towards the normal. When light enters a less dense medium, for example air, it bends away from the normal. Okay, so this is a little activity I want us to do, and you can find this on Satchel 1 as a Word document, or you could just use the one on the presentation. Now, basically, we've got a number of captions here. You need to match them with the image. Now, do note that 2 of the diagrams match 2 of these captions or these phrases here. So I'd spend no more than 5 minutes doing this activity. All right, pause the video here, have a go. Okay, so here you've had a go at that. So let's quickly go through the answers. So here we can definitely see it's diffuse scattering. All right, now here we've got air going into glass. So we've got light moving from air to glass and also slowing down. So this has got 2, right, air to glass and slowing down. Here we've got it going refracted from glass to air. So it's speeding up. All right, so there's 2 things to tick off there, glass to air and speeding up. This one is the incorrect law of reflection drawn. You can see that it's not a perfect reflection going on here. The angles are not the same. This is the normal line correctly drawn. This is the reflection, law of reflection correctly drawn because the angles are equal to each other. Remember, angle of incidence equals angle of reflection. Number 7 here, the normal line drawn incorrectly. The normal line must be drawn at 90 degrees to the surface. And finally, this shows specular reflection, just like you'd see in a mirror. All right, now, for most of you now, you can move on to the evaluation form. Anyone who needs a bit more of a challenge, feel free to do this little activity where you're writing your books as many applications of refraction as you can. For example, glasses, people who wear glasses, this is a good example of refraction. The glasses bend the light, so it strikes the retina in the eyes at the correct angle so we can see. So this is an extra activity. If you want to send it through to me on Satchel 1, I can award you some extra house points for this. All right? It's not a required activity though, so you don't have to do it. Now, what I want you to finally do is fill out the evaluation form, which should pop up now. All right. Thank you, everyone, for being here, and I'll see you in the next episode.